Dan Billow from WESH. One and a half questions. The half question is an 0017 launch window opening, meaning an 0023 launch. And the question is, if you can't open the valve, I mean, if you can't drain the hydrogen, how bad could that be?
Let's see, on the launch window, I think it was, if you do the seconds, it was 0022, but I didn't write them down. But yeah, that was window open, so 5 minutes later would be our preferred launch time. So I'll take the half question. I'll give the full one to Pete.
Well, there is an alternate drain path through a PV13 valve, but it would take an extremely long period of time to go perform that drain, and so it's not something that we would want to desire to do.
What's the hazard with that?
Well, I'm not sure what the vent path, if there's a different vent path for the hydrogen system, or if there is greater hazard. It certainly will extend the period of time to perform drain. I'll have to get back to you to let you know if there's any significant increase in hazard.
And it plays into the why you're draining. If it's just a weather turnaround, you're draining, taking longer, probably not that big a deal. But if you're in a pad abort situation where you've had a main engine abort on you, you probably don't want to sit there and have hydrogen on the pad twice as long as normal. So that's really the reason why we don't want to. We want to assure ourselves a good drain system.
Okay, any more on this side of the room before I make you go back around? All right, I just have to go around to the back there, sorry. And allow people to leave.
Hi, and thanks. Greg Dobbs from HDNet Television. And Pete or Mike, you've already said obviously you can't predict the outcome. Can you predict the point at which you're going to know whether it is, relatively speaking, just instrumentation or something worse? At what point are you going to know we can't go Thursday night, Friday morning?
Let's see. We talked based on when we get inerted and safed out at the pad and can allow the conditions basically to a point where we're ready to cycle the valve again. That'll probably be tomorrow afternoon. I don't want to put an exact time on it, but we're looking 4, 5, 6 o'clock tomorrow night. The engineers will true over the data. So basically around this time tomorrow, I think we'll be ready to have a technical discussion amongst the experts to say, did that look like what we thought it did? Do we think we're in good shape? So heading into the midnight time frame tomorrow, we'll probably know whether we're going to keep pressing forward or we've learned that we're not going to make it. So that's kind of what I'm looking at timeline-wise.
Yeah, Bill Harwood again. I apologize for asking this question because I fear we'll be here all night, but no. There's an outboard fill and drain valve, an inboard fill and drain valve, and in between there's a line that runs to the manifold, I guess. I don't understand how those valves operate normally. And I guess the thing has to also open for vacuum inerting in orbit. Is there any way to give a 30-second kind of what this system does? Maybe impossible, I don't know.
Yeah, I was going to say the simple version is really kind of just what you said there, Bill, that there's basically 2 valves in series, and then there's a topping valve that comes off to allow an alternate vent path. And so both those valves open up while we flow the propellants through. Once we're done, you close them in a series as you head into reduced fill and then into replenish. They're shut off for replenish. Then once we've lifted off and you hit MECO, and we've separated away, those valves are closed, which gives you the good interface. After we've separated away from the external tank, they open back up to then vent the system back out. The LH2 system vents out through those overboard drip valves. And so in that scenario, if one of them didn't open, you'd have to go through. We have an alternate set of overboard reliefs for RTLS that we use to get a faster inert. So you could go to that system and do your vacuum inert if you had a problem with one of those valves in orbit.
Freelance then is the inboard closes cycles first, and then the outboard at the T-minus 47 seconds or whatever.
Yeah, that one I don't know enough to be able to answer exactly. It sounds like what they briefed me on, but that went in one ear and out the other with all the rest of the schedule stuff we were talking today.
Thanks. Okay, Mike, and then we'll take one more.
Mike Schneider, Associated Press. Just to ask you about the schedule again. If you can't make August 30th, it goes into October, I take it, and then if you launch in October, are you still going to be able to get STS-129 off in November?
Yeah, if we went to October, it would be sometime around the 12th, the 10th, the 17th. I forget. There were various scenarios that had to come into play. There's the HTV, a Soyuz or 2, and a Progress, and we have to make sure they're either undocking before us or out of the way. And so depending on how much of that we were able to work in series, it would set the exact day we're ready to go launch. But mid-October would be what we'd be looking at if we don't make the end of this window. And then if we find ourselves in October, then 129 wouldn't be in November. It would bump out. And I don't remember exactly what we would bump that to. But the manifest guys are already doing their what-ifs on that. I just don't remember their answers.
I think we'll take our last question there.
How many valves like these have the shuttle, and what do you think can be the cause of this problem?
Well, there's two on each vehicle, so two of these big 8-inch fill and drains. As to the cause, there's a couple different things. The failure mode we've seen is this galling of the metal. Basically, the metal rubs and binds itself up and creates some debris, which then limits the travel and causes a lot of extra torque to go in the system as it tries to move. So that's the failure mode we've seen before, is that kind of debris generation, just because this thing is a big, complicated, rotating piece of machinery, and if the lube wears out, it just starts to bind up on you. What happens is these little limit switches are literally just little tiny pieces of metal that, as this little camshaft rotates past it, it pushes it down and makes a little electrical contact, which sends a signal out. For that, you could have any number of little things that either prevent that from happening, or perhaps there's just enough debris in the way that the valve gets closed but doesn't quite get over center enough to push that contact down. How it's all rigged up becomes a question. We see this on a lot of other valves like it. The reason why we treat these a little different is they're in that cryogenic temperature environment of dealing with liquid hydrogen, and you really need to be sure exactly what you have in that system, as opposed to just a water line that doesn't quite give you a closed indication when you shut that valve.
Okay, that was our last question. Let's see, given the 48-hour turnaround, we are not planning any news conferences tomorrow. I don't think these gentlemen have any problem with that. Unless something dramatic happens, and we'll get the word out if that's the case and make the announcement. For a launch on Friday, August 28th at 12:22 a.m. Eastern, we would have NASA television commentary begin at 2:45 p.m. in the afternoon, then a little before 3 o'clock would be the start of fueling. So taking coverage begins at 2:45 p.m. Eastern, and then continuous coverage would start at 7 p.m. So until then, if you want information on the mission, go online, www.nasa.gov/shuttle, and we'll see you then. Thanks.